Analyzing graphs. How can you describe a relationship given a graph and sketch a graph given a description? Well, first we have to remember that the first quadrant is the real world. Everything that goes out in the real world is happening in the first quadrant. Our question then is why? Well, because in the real world, we don't really have negative measurements. Time is positive, distance is positive, and things like that. And because of that, that's why things occur in the first quadrant. Now we're going to be looking at what sometimes are referred to as piecewise functions, or functions that are made up of different lines going in different directions. So we need to get some words to go with what we're looking at. So here we have 3 lines, and they're all going basically in a positive direction. And we're going to take this though in relationship to temperature, height, and distance. Some words that we might use instead of positive, we might say climbing, like a climbing temperature, or an increasing temperature, or that distance or height is going up, or temperature is rising. These are great words for us to use when we talk about things that are going up. Now, you can see by these lines, number 1, number 2, and number 3, that they are going in different degrees. So we need to understand it's not just something that's increasing. We need to have an adjective in there as well. So here at number 1, we can say that it is increasing slowly or gradually. Here at number 2, this will be our average, pretty much right in the middle at a 45-degree angle. That's an average ascent or an average climb. And here at number 3, where it's going a little bit steeper, it's rapidly increasing or dramatically climbing or quickly rising. So we want to be able to know that when we're talking using words like that, it's actually becoming very steep and as steep as it can get. Now let's take a look at going the other direction. Here we have 3 lines and they're going the other way. And again, the same idea, 1 being that it's barely happening, 2 is an average, and 3 means it's happening dramatically or rapidly. So here we have decreasing or dropping or perhaps sinking, going down, or even falling. These are all great words to tell us that something is going in the other direction, that it's going down in relation to temperature, height, or distance over a period of time. Now here, when we're looking at this one, which is going straight across, you'll notice I only have 1 line because we see it's not changing. Since it's not going up or down, we're going to have some other words like steady, the same, not moving, stable, stopped, or pausing. These are all good words to let us know that nothing is really happening. There's no change going on over a period of time as time elapses. Let me show you what I kind of mean by this. Here I have a little drawing, and we can see here this red line and this green line. And the difference between the red line and green line, hopefully, that we realize that the green line is moving a lot faster at a steady speed. Even though the red one is a steady speed, the green one's traveling faster. Here, we're at a stationary pace in the middle, and then we're returning back to the start. Now, this is over a period of time, and here we have time elapsing in over 9 minutes. We can kind of use this story as if I'm coming from my classroom. In the morning, I decide I'm going to walk up towards the office, and I may stop to talk to a teacher. As I stop to talk to a teacher for a little bit, I may forget why I had to go to the office, so I return back to my room. We can have a second scenario going on with the green line saying it is almost the beginning of the school day, and I have forgotten to check my box up in the office, so I might walk a lot faster to get to the office to get what I need. So those are some ideas of how this works. Now we're going to put together a story by looking at a graph. We can see in this graph that over a period of time, which runs about 5 minutes, this is our distance from home to school, being that the origin is going to represent home and the further away from home is going to get us to school. We can see that this graph is separated into 4 areas. And we're going to label those areas A, B, C, and D. And we're going to start to see if we can tell a story. Now, this isn't the only story that can be told for this graph, but it gives an idea of what's happening. We have to remember, we see that 2 things are in a positive motion, A and D. Things are going away from home. We have C, which is negative, which means coming back towards home, and B, which means that it's not moving in any direction. So let's see if we can tell a story about this. So starting with A, how about you're walking to school with your friends, starts for a couple of minutes, and then you're going to stop at the crosswalk and wait for traffic. And you think you forgot something and start to walk back towards home, and here you found it and realize that you are late and start to run towards the school. You can see the steeper incline, so it's going a lot faster. Now let's see if we can do it the other way around. Let's take a look at 2 different graphs here and pull out a description. It says a woman climbs up a hill and then runs down the hill. So we need to put in two lines here. Let's talk about running or climbing up a hill. Now, here's an average speed as we were talking about earlier. Probably climbing up the hill, she's not traveling at a constant pace. She might be going a little bit slower, still positive. She's not crawling. That would be crawling up the hill. She's still going, but maybe not necessarily at an average pace. And then we need another line, which will help us to say that she's running down the hill. So we know that running is going to be, it's not going to be straight up and down because that would be falling off the cliff, but she's coming down at a much faster pace. So our line should look something like that. In the second example, this one says a child climbs up the porch steps and sits there while reading a book. Well, we know that, let's say there are 5 steps on the porch. Child probably climbs, and we're going to say maybe a small child. We're going to give them just a little bit of time to get there, not going very fast. And it says they're going to sit there and read a book. Well, if they're going to sit there and not move, we're going to have a flat line. So that kind of gives us this idea. So hopefully this gives you a little bit more of an idea of how to analyze a graph, or what we call a speed graph. They are also called piecewise functions because they're made up of a bunch of different pieces. There's a great website I want to show you right now if you want to practice on your own. It's called Graphing Stories 15 Seconds at a Time. There are different little short videos that you can watch and practice graphing these piecewise functions.